Okay, I think it's 1 o'clock. Welcome everybody to another HDF clinic. Lots of exciting things happening in the HDF world. We have our usual motions, but before we go there, I checked our Google sheet. There weren't any questions there, but I'm going to pause and ask, are there any questions at this point?
No questions, Gerd.
Okay, thanks. Great. Okay, then let's jump right in. Let's talk about last week's highlights, announcements. We just announced there's going to be a webinar on H5 Web, and more specifically, since it builds on that H5 Web module or technology, there is a VS Code extension, and we talked about that in the past, and so the author will talk about that. Lori has her hand up. Lori?
Yes, so you are correct to point out in the next line about the date. The date is correct, time is wrong. So it is for Central European time, 4 p.m. in the afternoon on a Wednesday, which will be 9 a.m. Central here in Illinois, where our home base is.
Okay, so let's correct that. Yeah, because I copied it off the registration page, I think, and I looked at it and I thought 4 p.m. Central, maybe okay if we want to be accommodating to, let's say, the West Coast or something like that, and the outer island.
I have fixed it in print, I think, everywhere other than in our newsletter, which is, you know, committed forever now. But no, if you go to the registration link, it should show the correct time. Okay, great, good. Yeah, that was my next question. And obviously, free registration, so please go ahead and register for that. And it's going to be obviously a fun talk to get it straight from the authors who develop H5 Web. And in fact, I mean, we, of course, we are working, that's no secret, we are working on redesigning our web page, I mean, the web page for the HDF group. And we would like to include H5 Web in some form. So for example, yeah, somebody comes to our website, they just picked up an HDF5 file somewhere and they're saying, well, what is that all about? What am I going to do with that? Of course, it's still then a little bit of a step to say, I got an HDF5 file. How do you make a connection or an association with our website? And then let's say you pass that hurdle, then you come to our web page. At the moment, the web page would tell you all kinds of great things about HDF5, and you might find yourself asking, well, that's great, but what am I doing with this HDF5 file? And so we want to make that a lot easier, that in the simplest case, yeah, you can just drag and drop that and then get at least a sense of what it is that you are looking at there. We also have quite a few job postings right now that we just posted last week. So we have 3 open positions at the 3 positions announced. We have a need for more than 3 people, but let's start with 3. So there is a position, and they are all linked here: HDF software engineer, a software engineering position with a little bit more of a cloud focus, and then one with more of an HPC focused, and then yeah, please reference the descriptions. But yeah, we hope that we'll find a lot of interested applicants, and yeah, we'll hopefully have some interviews and some new hires eventually pretty soon. There's also a great new blog post by John, and John, probably this was triggered by some development that he did with H5PyD, but also he got some new hardware, and sort of taking all that together, this blog post is about Hsds Streaming. And if you remember, we talked about this maybe 5 or 6 clinics in the past, where with their version of HSDS at the time, when you requested a either a read request or a write request, and the size of the request exceeded this configurable max request size limit, and I believe the default value for that was 100 megabytes. If it exceeded that, then it would just fail. And John corrected that by introducing HSDS streaming, meaning that if it takes longer to process that request, or the payload, the request size, the response size is greater, let's say 200 megabyte, and I believe that's the example that he actually uses in this blog post, then the server will be streaming in increments data back to the client, or the client will be streaming that data that are part of the request to the server. So this is what this blog post is about. And then also he just got some new hardware. And so he did a little bit of a performance comparison between HSDS and the HDF5 library, and then his MacBook Pro or Mac Pro, which is a little dated at this point. And he got a new device, this Dev1 machine. And yeah, he just compares the numbers, and it's very interesting. So I highly recommend to read it. Okay, I'm going to pause and ask any questions so far. For those of you who are here, no? Okay, then I'm going to jump into the forum. So remember, yeah, last time we briefly talked about this allocating chunks in a specific order, and one obvious way. So the short answer is that, or maybe before I come to the short answer and answering, what is the use case? I think that's where we left off the last time. We said, that's great, we can mimic that behavior if you want, but what's the use case? And the use case, the user wrote back and said that in the ZAR specification, there is this concept of ZAR shards. And you might say, well, what is a ZAR shard? It's in a way, in HDF5, we have this concept of chunks, and ZAR sort of adds an additional level of tiling or chunking or whatever you want to call it, partitioning. So they have a higher level concept, this concept of a shard, and then a shard can have multiple chunks in terms of the storage of this shard content. And what the user had in mind was to say, well, I could have a ZAR shard where the physical data of that ZAR shard is actually stored in an HDF5 file, more specifically in HDF5 chunks, in chunks of an HDF5 data set. And that's an interesting idea. I would see a few issues with that. So number one is there is currently no API to accomplish this, what the user is asking, meaning allocating chunks, HDF5 chunks, that is, in a specific order. That's completely handled internally by the library. And I could also see a few issues, and more experienced HDF5 users and developers probably would see many more. Number one, you would be relying on some kind of implementation details. So right now, it's very likely that if you allocate chunks, or if you write to chunks in a chunk data set in HDF5, you could say, what are my chances that these chunks will fall at monotonically increasing addresses in the file in terms of file offset? I think the chances are pretty good. However, making that assumption, you would rely on all kinds of implementation details that might change in the future. And so that's definitely not a good thing. Number two, exposing that type of information to the outside world is also problematic, in a sense that this would impose certain constraints on the library and also tool behavior. So for example, if you think about running H5 repack, okay, you could say, okay, I'm going to do this read only. So I'll create these ones and then write the data and will never touch it or modify it again. That's fine. The HDF5 library is designed for many more use cases. So write once, read many is an important use case, but for the HDF5 library, unfortunately, not the only use case. And so and we are not going to change that assumption just for considerations like that. So it would impose an undesirable constraint on what the internal memory management can or cannot do if we were to do that. And then also tool behavior. So just take the simplest example, H5 repack. H5 repack is free to move things around and in particular chunks and other things. And so very likely whatever information you may have gathered about the location of chunks will be out of date or at best uncertain at this point. And then there are potential performance impacts as well. So for my money, I would say, well, first of all, I would try it. And last time we spoke about if you want to simulate this to see what the real performance benefits are, because there might be performance benefits for certain types of storage, but then those performance benefits may not be there at all or be actually counterproductive for other types of storage. So this is another problem. That's what I mean by performance impact. It may not be portable. So whatever you tweak and tune for a particular type of data store or storage capability, that whole behavior may be completely different for another data store. But yeah, so for research purposes, you could mimic that by just choosing what we call external layout. So you can allocate a file of a chunk or multiple chunk sizes in the underlying file system or data store. And then you do, in a way, chunking by hand by just keeping offsets in that external file. This is actually what you use when you define this data set with external layout. That's how you define it to the HDF5 library. And that way you could at least explore, well, is there really the performance benefit there that you were hoping for? And because if that's not, well, then changing the library just to find out that it's not really that useful as you thought it would be is of course not very helpful. So yeah, I think there's no API. And I mean, Dana, I mean, what would you say as sort of the engineering chieftain? How do you approach or feature requests like that?
I think that when people want to make changes like that to the library, you have to make a very clear case for why it's actually an improvement. I mean, everything. One of the problems that we've had is that the library is 25 years old and has 25 years worth of stuff jammed into it. So if we just keep throwing everything that we think might be useful into it, it becomes a very unwieldy piece of software. So we want to see things have a clear benefit and a clear way of being integrated into the library. And if things don't make that cut, then they don't go in.
Okay. Okay. Then there was another sort of, I call it blast from the past. I remember that discussion probably a year or two, or maybe even pre-COVID. I forgot to look at the dates. That was actually an interesting discussion, and I'm personally very interested in that discussion. A user was basically reviving that discussion around machine-readable a machine-readable format for units, for physical units, that is. And so from my perspective, and by my perspective, I mean, we actually had a proposal actually around the time when that discussion got going, that from an HDF perspective, I think it makes sense to attach or express, represent unit information in a data type, in an HDF5 data type, for mechanical reasons, but also for conceptual reasons. First of all, when I say anchor that in the type, what I mean is that, yeah, this thing 1.0 meters as its physical unit is an element that is of a different data type as the element that we call 1.0 seconds. These are
elements of completely different types. I mean, you could say, well, they both look like round spheres, yeah, but metaphorically speaking, but then there are sort of green spheres and blue spheres or red spheres and whatnot, and they are different. And so you wouldn't consider them elements of the same type. I mean, if you have sort of, call it a forgetful operation that strips of the unit aspect of that, is the number 1.0, which is just one aspect of a quantity that has a unit attached to it, is the forgetful operation take of the value 1.0 the same as 1.0, obviously, yes, but unit changes everything here. And can there be unit-less things? Yes, absolutely. But to me, the unit should live with the data type. And on the mechanical side, I think what would be the advantages would be that when people talk about units, obviously there are different unit systems. I mean, there's the SI system, but then regionally there are other systems for regional and historical reasons and so forth, and that's fine. I think, I don't know, I'm not an expert on the unit folklore or sociology of units, how likely it is that we will wake up one day and everybody uses the SI units or something like that. I don't know how likely that is. But be that as it may, in the same way that you can have user-defined data types, if units went with a data type definition, you could have user-defined units and user-defined unit systems if you have multiple units. Likewise, we have this nice, I think, data type conversion pipeline in HDF5. So things like unit conversions would naturally, in a way, fit into that mechanism. So you could do unit conversions as part of that data conversion pipeline. And likewise, I mean, you could do things if you want to, for example, if you want to convert meters to seconds, which would be wrong from a unit perspective, but there might be some reason that you might want to do this. Yes, you can create, as we can create soft conversions where we can convert bit fields to compound data types and all kinds of other things. You can do that, but at least then you can sort of point your finger at and say, if things go wrong, well, this is why somebody consciously, intently converted meters into seconds, and that's where the problems come from. And maybe at the time, yeah, when we wrote this proposal, unfortunately, it wasn't funded, it wasn't accepted, the reviewers didn't really see the merit at the time, but it's something that I'm somewhat passionate about, and I think to me it's something that would make HDF better practically and otherwise. Because if you followed this a little bit on the algorithmic side, in C++ and Python, there are pretty sophisticated libraries that when you, for example, write down an algorithm, they will check whether the operations that you are doing, the assignments and whatnot, the arithmetic operations, are really consistent from a unit, from a dimensional, as they call it, perspective. So what's in a way missing is making that connection from that compiler assistance or runtime assistance to the data. And with a mechanism like that, that could actually happen. But again, it would need some funding and some development. But I think the sort of the slots or the anchor points where this whole would feel very natural are there in HDF5, at least in my mind. And okay, and then there was one more, and I'm going to use that for tips and tricks if we get to it. But somebody was asking about reading a compound data set. How do I do that? They want to write some generic code and so forth. So I'll come back to that in a moment. But I will yield the floor to Dana to tell us all the interesting things that are happening in engineering.
Not that much. I mean, we just released the HDF5 1.13.2. That was last week. There's the 113.3 will come out in October. And hopefully before this week's over, I'll have an updated schedule on GitHub that includes 2023. Tentatively, we're not 100% for sure when we're going to be releasing things. We don't have any contractual obligations. So these are just kind of ideas that we have right now, but it gives people some ideas for, I guess, for some planning. As for the, what do you want to see in HDF5 2.0? Yeah, people are still talking on there. Nothing in the past week. I mean, yeah, it's the one thing that came up on there is somebody pointed out that it's a problem that we have 32-bit size, 32-bit chunk size that keeps you from having a getting rid of the contiguous data set layout, which we'd have to keep around for historical purposes. We can't get rid of that. But yeah, but not a whole lot going on there, just continuous development of features. Slowly push the library in new directions.
Yeah. I think for legacy reasons, but also otherwise, I'm not 100% sure that contiguous versus single chunk, if I quite buy that argument. I mean, I at a technical level, I have some sympathy with it, but to me, in a way, it could go also the other way, in the sense that if we decided for some reason, and it in a way relates also a little bit to this earlier discussion where, well, you want to take control of where chunks can be allocated, or you can allocate them, and not so much where they can be allocated, but in which order they can be allocated. It always goes a little bit in that direction of exposing things that are really library internal, in the sense that you don't want to make any guarantees or any commitments to the users that they come to rely on and they think they can exploit and so forth for all kinds of reasons. And then at some point, when you change a detail in the implementation, sort of all hell breaks loose, because people were just making assumptions that they thought were the most natural things to do. And likewise here with this chunking, what if chunking is just, I mean, I treated it always a little bit as a logical recommendation. I'm telling HDF5, number one, if I use unlimited dimensions, for example, I'm not really sure how much stuff I'm going to get, number one. And then to say, well, typically I'll be accessing this data in granules like this, or in quanta like this. And it was a recommendation to the HDF5 library. And if the library, for example, decided, well, that doesn't look like a good chunk size, I'm going to use something else internally, then that would be fine, because it's completely opaque in a way to me how the library at the end of the day implements these chunks. Of course, you could now say, well, okay, we caught ourselves in that trap because we are doing H5D write chunk and H5D read chunk. And again, it's a slippery slope. Once you go down there, then yeah, you might regret it, or you might see, well, I opened the door just a little bit, and now people want to really sort of make the door wide open. And
right, yeah, this is, I feel like, yeah, that there's having chunks. I mean, they really are supposed to be an internal detail, but they're not really an internal detail, because if you guess wrong, I mean, that's one of the easiest ways to get poor performance out of dataset writes, is to have your chunks be pathologically sized for your IO patterns. And we've got a bunch of slides and stuff that talk about this, about how you depending on the size of your chunk cache and stuff, that you can really come up with some bad ways of doing this. But what people have realized is that you can get significant performance gains by just directly scribbling bytes to disk. I mean, that's always gonna be the fastest way of writing, is if there's nothing in between you and your storage, then of course writing is as fast as possible. And so that's what people really care about, I think, is performance. And they've discovered that there's tricks that you can use if you can directly scribble to it. And so we expose stuff so that people can see this. And yeah, unfortunately, they're looking at what was before an internal detail, and now we've exposed that publicly. And do we need to revamp that for HDF5 2.0? Maybe, right? Maybe we need to go through and look at that.
Yeah.
And think of a better way of exposing some of this stuff. But I think that this idea that people are going to want to have direct access to the storage, that's the thing people, or to at least where the raw data goes, that I think that's something that's not going away. And I mean, it's a powerful thing, but it's powerful in the same way that, like, hand tuning assembly is powerful, right? Like, it's not a thing for everybody, but for people who really care about that sort of thing, it can be a crucial tool to squeezing out the performance that you need. I mean, the reason it was created was for the light sources that needed to, they had ASIC compression, and they just wanted to write their bytes as fast as possible to the disk. And then later, when they were reading it, they didn't care if that was not quite as fast, but they definitely had to spill out what was inside the detectors to disk as fast as possible because more data was coming. And so for some people, these things are critical, and we just, I think we just need to be a little more careful. I mean, it's not that I wouldn't say that interface was sloppy, but it was just it was, in fact, it's worked out very well, I think, for the people who have had to use it. It's just that it exposes a lot of internal things, and and of course, now people want to extrapolate, right? And I think that's kind of like what we get with the czar thing, where like, oh, I want to access these chunks in a specific pattern, and it's like, and is that a thing that we want to allow people to do, right? I mean, this is some of the parts of the library. This almost precedes my time with the company, but I thought the idea about, like, kind of like the way that metadata cache and stuff is struggled is that we wanted to have things more component-like, so that things can be substituted in and out more easily, and people could have different strategies. And it could be that we have like a chunk strategy thing that we implement and let people play around with, come up with their own algorithms for it. And that's a thing that potentially we could do. But it's
okay, good. Okay, so I'm going to speed up here, tips and tricks. So going back to this user's question, he was basically saying, okay, somebody gives me a file with a compound data set and varied field names and varied types, but let's, for argument's sake, assume that the types are limited to arrays of integers or doubles, and then all the fields are doubles themselves or integers. He wanted to know, well, how do you create generic code where he wants to just pick out a specific field? And I think it all comes down to really the question of what I would call HDF5 compound data type introspection, and more specifically in the C++ context here, for what is known at compile time. That is really the crucial questions if you think about writing const expressions or templates, or do that type of programming, or whether you can find out certain things only at runtime when you look at some data. That's really the deciding question here. And there are fundamentally two approaches that you can take here. And I'm just looking at the list here. Unfortunately, Stephen is not here. I was hoping he would be here, Stephen Varga, who sort of has done a lot of work in this space. To me, there are basically two scenarios here. The first scenario is if you know at compile time that field name as a literal, as a string. So you call that field is called foo. And you know the in-memory type of that field, meaning it's an int, or it's a float, or it's an array of integers of something of fixed size. If you know that, you can definitely write down a const expression or a template that will read that into that memory type. No problem, as long as the field name really matches the field name, because the H5D read call, that's how reading individual fields, picking individual fields of a compound type is based on name matching. And so as long as that name or the names, that could be multiple, match, you're good. However, if you know the field name only but you do not know what the type of these fields is. I believe, and that's why I was hoping Stephen would be here, because he would correct me. But for now, I'm just going to say that I think if you know the field name only, unfortunately, constant expression or templates are not going to work, because you will really have to find out what the size of an element of that type is, because without that information, you can't really allocate a buffer to read into. So it's not something, in my opinion, that you can figure out at compile time. So then focusing on the second case here, the sort of data introspection algorithm in double quotes would work a little bit like this. Well, first of all, for the field, but for simplicity, I'm going to assume it's just a single field, but it would work with multiple fields exactly the same way. You know the field name foo, for argument's sake. You would retrieve, then you would have to figure out in your compound type in the file at which position in that compound type, or as we call it, the index, with this function h5t get member index, you would figure out, okay, at which ordinal position is that field located? Is it the first, the second, the third, and so forth? And then you could retrieve the type at that position. You could the type class in the HDF speak, or the member type, both. You can retrieve them with these two functions. And then, since you want to read that field into memory, of course, you would have to determine the in-memory, or in HDF speak, that's the so-called native type. You would have to determine the native type with h5t get native type. And then once you have that, of course, you want to know, well, how big is actually an individual element of this type in memory with h5t get size. And then you have, in a way, all the pieces of information that you need to construct a compound type that in this case has one field, or if you want to read two fields, it would have two fields. You would basically construct an in-memory compound type with the number of fields, as many as you want to read. If it's one field, it would just have one. If it's two fields, two, blah, blah, blah. And then, of course, the name has to match. So you would construct that in-memory compound type with h5t create, and then insert the individual fields. The order doesn't really matter at this point, because the matching is based on names. There is maybe a certain performance penalty involved if you do it out of order, but fundamentally, HDF will do the right thing regardless the order. And then you would have to allocate, depending on how many elements you want to read of the right size. And then you just call h5d read, where the in-file data type is your compound type, and the in-memory type is the type that you just constructed. And then you would just have to go in and parse the buffer, because obviously you will allocate this sort of as a vanilla buffer of unsigned bytes, and then you would have to go through and cast the individual elements to the type that you expect for that field. But that's pretty much it. So at runtime, you really have, if you know only the fields and you do not know the size of the data types, you have to go through this. This is, to my knowledge, the only way that you can do that. But I will, maybe later in the week, I get a chance to speak with Stephen, if that's really true. I mean, I believe that, yeah, without knowing the size of the data type in memory, there's very little that you can do with const expression or template, because the compiler wouldn't know what to allocate. And but then there might be something that I'm missing here. So I'll report back next time if I said something wrong. But yeah, so this is the generic, and this applies in a way for any HDF5 data type, whether it's compound or not. If somebody gives you a data set of something and you want to programmatically sort of understand what is that element type that I'm looking at here, this is how you would go about. I mean, you would first retrieve the class. If it's compound, then you do what I just described here. If it's an enum or if it's something else, well, then that process is maybe a little easier because there's less to parse and less to understand. Okay, and that's all we have time for. We are 5 minutes over time already. My apologies. Thanks for coming, and see you next time. Yeah, bye.